In this video, I'll show you how to use Gremlin to test the resilience of your Kubernetes clusters to pod failures. Pod failures are extremely common in Kubernetes, and while Kubernetes is designed to automatically detect and replace failed pods, this doesn't always work out as planned. You might run out of cluster capacity, or applications might crash on restart, or worse, our pods might not be restarted or rescheduled at all. We'll use Gremlin to validate that our cluster is resilient to pod outages, so we're prepared for any production incidents. Our example application is an online e-commerce shop called the Online Boutique, which sells a variety of accessories, clothes, and trinkets. We're running this on a 3-node Kubernetes cluster on a public cloud provider, and the application itself consists of 12 deployments with 1 replica each. On the right side of the screen, I have 2 terminal windows open running a tool called K9s. The top window shows the 12 deployments, and the bottom window shows our 3 worker nodes. We're going to be focusing on the front-end deployment, which is the one highlighted, and is responsible for handling all customer traffic and rendering the website. If this goes down, then our entire shop becomes inaccessible, so we want to make sure that it's resilient. We'll do this by using Gremlin to terminate the pod itself, then monitor that top K9s window to make sure that it restarts successfully. We'll also refresh the website to check for errors, unusual behaviors, or downtime. Our hypothesis is that Kubernetes will immediately detect the terminated pod and provision a new one to take its place. And while there may be some downtime, it should be minimal, and the site should come back almost immediately. Let's give it a try. First, I'll open Gremlin. Next, I'll select my attacks, and then click New Attack. And we're targeting a Kubernetes deployment, so I'll select Infrastructure, and then Kubernetes. I'll make sure that the correct cluster is selected. Then I'll expand Deployments, and select Front-End. Next, I'll scroll down, I'll click Choose a Gremlin. I'll make sure State is selected, then I'll select Shutdown. I'm going to decrease the delay to 0 so that the shutdown attack starts immediately. Then I'll uncheck Reboot, and I'll click Unleash Gremlin to start the attack. And while the attack is running, I'll monitor the state of my pod using K9s. This should show us any changes as they happen. And shortly after the attack starts, we see that the front-end deployment is reporting as unavailable. So now if you go back to our website and try refreshing, we see that it's hanging while loading. The front-end pod is reporting back as healthy, which indicates that Kubernetes did detect the failure and restart the pod. However, because our website is still loading, customers may be noticing a delay. So if we try refreshing the page again, we'll see that it reloads immediately. And now I'm able to browse products again. So our service was restored fairly quickly. We should try to avoid this downtime if we can. We could simply scale up our deployment so that we always have at least 2 front-end pods running. That way, if one fails, the other can pick up the slack while Kubernetes restarts the failed pod. Another option would be to have some sort of cache in front of our front end, so that even if our entire cluster goes offline, we can still handle and respond to customer traffic. Once we have our fix in place, we can repeat the experiment to make sure our solution works as expected.